we will discuss some of the GATE questions from network basic topics which has been appeared over the years. Let us start. Somewhere around GATE 2009, in the interconnection of the ideal source shown in the figure, it is known that 60 volt source is absorbing power. This one is absorbing power. Which of the following can be the value of current source? So from the power conventions, we know for any element this is the positive voltage and this is the positive current. So P is calculated V into I. If P is positive, power is absorbed. If P is negative, power delivered. So that means in which case P will be negative? If this is the current I minus I. So in this case V into I will be the negative. In this given questions, the I should be positive and flow in this direction for power being absorbed by the 60 volt sources. That means once that 12 amperes current is coming, so some current will go here and less than 12 ampere will be flowing through this current source. That means this current source should have a current less than this. So out of 1, 2, 3, 4 options, only this one is matching. With the equation also you can write, that is this 12 ampere is equal to capital I plus small I, as both are positive because all the options here positive. So I should be positive and also small I should be positive because power is being absorbed. So capital I should be 12 minus I. So your I must be less than 12 ampere. These conditions is satisfied only by option A. So this is the answer. We'll move to the next question. This is a GATE 2012 questions. It has been given that VA minus VV equal to 6 volt. This is VA, this is VV is equal to 6 volt. So that means VA minus VV is equal to 6 volt. So what should be this current? I is equal to VA minus VV upon 2 because 2 ohm. So 6 upon 2, that is 3 ampere. That means here the current is 3 ampere. So whatever the circuit this side, we least bother about, because once current goes through this branch, it has to return, right? Here is also I equal to 3 amp, same current, and here your 2 ampere current, here 3 ampere current is coming. So how much current is flowing through the 1 ohm resistors? 5 ampere. So VD minus VC, this is your VC, node voltage of this node, this one, and this is your VD, is equal to, this potential difference is the this current because this is positive, this is negative. So 5 into 1 equal to 5 volt. But question is not yet over because they have asked VC minus VD. So VC minus VD is equal to minus 5 volt. This is a 2 mark question. So easy. Just application of the basics. So option A is the correct. Next we will move to the another questions. This was asked in the GATE 2013. In those days, there are questions like common database questions, that is common data for the question number 50 and 51. So it has been given a current source 2 ampere, this is the 5 ohm, this is the 10 volt, this is the 2 ohm, and this is the 1 ohm. The current in the 1 ohm resistor in ampere each. That means we need to calculate this current. You see that there is a 10 volt voltage source across 2 ohm resistors. Current through this resistor will be the 10 by 2, which is 5 ampere. Current is 2 ampere, and here current is Is plus 5. How much current is this? 2 minus Is minus 5. This current. Now apply the KVL around this loop. So KVL around this loop is the 10 volt. I am encountering a 10 volt minus this current, that is 2 minus Is minus 5 into 1 ohm equal to 0. This current is your, so 2 minus Is minus 5 is equal to 10. So this is the current we record, because this is the current flowing through 1 ohm resistor. So this is the 10 ampere. So option C is the correct. The current Is in ampere in the voltage source and the voltage Vs in volt across the current source respectively. Is, from Is you can easily find out from here. Is is equal to 2 minus 5 minus 10, that is minus 13 ampere. Minus 13 ampere, only one option C. So this is the answer. Even I am not going to calculate the Vs. You apply the KVL around this. So Vs is equal to, I am traversing this way, 10 plus 5 into 2, that is 20 volt. Now come to another questions which has been asked in the GATE 2014. Consider the configuration shown in the figure, which is a portion of a larger electrical network. All the current have been marked properly. So given that R equal to 1 ohm, all these are equal to 1 ohm. Currents I1, write down here. Current I1, here it is 2 ampere I1. I4 minus 1 ampere, which one is the I4? I4 is the minus 1 ampere. Minus 1 ampere. I5 minus 4 ampere. Minus 4 ampere. Which of the following is true? So first you check, this is a 2 ampere. Here it is coming minus 1 ampere. That means current is going in this directions, 1 ampere. So how much current left? 1 ampere. It is 1 ampere. How much current going through this side? 4 ampere. 1, and it is going 4 ampere. So this current is your 3 ampere. That means your I3 is equal to minus 3 ampere. So this is your 2 ampere and this is your 3 ampere. So I6 will be the 3 plus 2, which is 5 ampere. Option A correct. Let us start another question. The following figure shows the waveform of the current passing through an inductor of resistance 1 ohm and inductance 2 Henry. The energy absorbed by the inductor in the first 4 seconds each. It simply is the energy calculations. So I can write I as the slope is 3t for t 0 to 2, and I is equal to 6 for t greater than 2. There is a discontinuity. As for the given questions, inductor can be represented as a resistance and a ideal inductor of 2 Henry, and this is your 1 ohm. That means the current source has been connected like this. It asked energy absorbed by inductor in the first 4 seconds. For energy, you know, should be V into I. We have I, but we don't have V. Let us calculate the V. V equal to R into I plus L di upon dt, which is I plus 2 di upon dt. So V will be 3t plus 6 for t greater than 0 less than 2, and V is equal to 6 for t greater than 2. Now we have V and I, so we need to find the energy. As per the relations, energy is equal to from 0 to t, what is the I? 0 to t, your I is 3t and V is the 3t plus 6 dt, and from 2 to, because up to 4 second, 2 to 4, I is your 6 and your V is also 6 and dt. So 0 to 2, 9t square plus 18t dt plus 36 into 4 minus 2, 2. From this we got 9tq upon 3 plus 18t square upon 2 plus 72, limit from 0 to 2. So this terms gives you 3 into 8 plus 9 into 4 plus 72. So finally 24, 36 plus 72, so 132 joule.